Hi, I am Lopa Mudrashen. Welcome back to my channel Electronic Science Tutorial. From today I will start a new lecture series on NTA UGC NET and West Bengal SET exam for Electronic Science subject. Those who are not check out my channel, please follow my channel. If you like my channel, then please do like, share and subscribe my channel. So let's start our class. In today's class, we discuss about the NTA UGC NET and West Bengal SET exam 2022. In this session, we cover in detail about this topic so that we can easily solve the previous year question paper of UGC NET Electronic Science. Each and every topic we can understand in easy and simple manner. So, let's begin our NTA UGC NET exam 2022 class. Okay. Today I will discuss one most common and important topic of basic semiconductor device, that is Fermi level. What is Fermi level? This is the diagram or band diagram of semiconductor device. This is the conduction band and this is the valence band. At the absolute zero temperature, that means when T equal to 0 Kelvin, the valence band being totally full of electron and the conduction band is in zero state. What does it mean? That means conduction band is in empty state and the valence band is in full of electron state at absolute temperature at T equal to 0 Kelvin. In this condition, the Fermi level, which is defined by EF, this Fermi level is the highest occupied energy level at T equal to 0 Kelvin, which lies in between the middle of the band gap for an pure semiconductor. So this is the conduction band and this is the valence band. So this is the band gap, the distance between the conduction band and valence band. We know this is called forbidden energy gap or band gap. So Fermi level lies near the middle of the band gap and which is called the highest occupied energy state for a pure semiconductor. So this is the Fermi level concept at T equal to 0 Kelvin. So when at absolute temperature at T equal to 0 Kelvin, when the conduction band is totally in empty state and the valence band is totally in full of electron state, the Fermi level, that means EF, lies near the middle of the band gap between the conduction band and valence band or the forbidden energy gap or band gap energy. Right? So this is the Fermi level concept at absolute zero temperature. How this probable distribution function we can represent? This probable distribution function is represented by NE divided by GE equal to F suffix capital F E equal to 1 by 1 divided by 1 exponential E minus EF by KT, where EF is called the Fermi energy. EF is called the Fermi energy. This energy which lies between the conduction band and the valence band. The number of the density Ne is the number of particles per unit volume per unit energy and the function is GE. which is the number of quantum states per unit volume per unit energy. Okay, and F suffix F E is called the Fermi-Dirac distribution function of probability, and it gives the probability that a quantum state at the energy E will be occupied by an electron, and E is the energy occupied by an electron. Okay. So this is the concept of Fermi level, where K is the Boltzmann constant and T is at absolute temperature. So this is the probability distribution function of Fermi level, that is Fe equal to 1 divided by 1 plus exponential E minus Ef by Kt, where Ef is called the Fermi energy, E is called the energy occupied by an electron, K is the Boltzmann constant, and T is at absolute temperature. Okay. So, how the Fermi distribution function and the Fermi energy has been calculated. First case, that means at the T equal to 0 Kelvin at absolute temperature when E less than Ef. When E less than Ef means when the electron energy is less than the Fermi energy. Electron energy is less than the Fermi energy level means the electron does not reach from valence band to the conduction band state. Right. So this is the condition when E less than Ef. At this condition, exponential part, that is the Fermi distribution function, we know 1 by 1 plus exponential E minus Ef divided by Kt. So the exponential part E minus Ef divided by Kt, if this exponential term when E less than Ef, the exponential is minus infinity. So that is equal to 0. So how we get, that is the Fermi distribution function is 1 divided by 1 plus 0, that is equal to 1. So in this condition we can say that the Fermi distribution function when electron energy is less than the Fermi energy level, we get the 1 value or unit value. Right. Second case, at T equal to 0 Kelvin, that means when at absolute temperature or at absolute 0 temperature, when electron energy is greater than the Fermi energy, that means when electron energy cross the Fermi energy, and it means the electron from the valence band, it reaches the conduction band. At this condition, the exponential part of the Fermi distribution function, that is the exponential E minus Ef divided by Kt, it tends to exponential plus infinity because E greater than infinite Ef, right? So this exponential part we get plus infinity, that is equal to plus infinity. And from this equation we get the Fermi distribution function, that is 1 plus 1 divided by 1 plus infinity, that is equal to 0. So Fermi distribution function when electron energy greater than Ef, we get the 0 value. Right. If this Fermi-Dirac distribution function we can plot for T equal to 0 Kelvin, this is the plotting. For T equal to 0 Kelvin, the electrons are in their lowest possible energy state, right? The probability of a quantum being occupied is unity for E less than Ef. This condition. Okay. And the probability of a state occupied is 0. This condition we reach when E greater than Ef. So all electrons having energy below the Fermi levels at T equal to 0 Kelvin. So this is the plotting of Fermi-Dirac distribution function, which we can plot from this expression, first case and the second case. So this is called the distribution function and the Fermi energy plotting. Okay. Now we change the electron distribution for the energy level at T greater than equal to 0 Kelvin. When E equal to EF, that means electron energy is equal to the Fermi energy level. At this condition, what happened? The exponential part of the Fermi distribution function, that is exponential E minus EF divided by KT, that is it tends to exponential 0, because when E equal to EF, so the exponential 0 equal to 1. So what is the Fermi distribution function? That is equal to 1 divided by 1 plus 1, that is equal to 1 by 2. So the half probability reach. So Fermi energy level is the highest occupied energy level, right? So when E equal to EF, that means when electron energy is equal to the Fermi energy, we reaches at the half of the energy state. So this is the probability of a state being occupied at E equal to EF, that is equal to half. Okay, and this is the plotting for the Fermi probability function versus energy graph. This is the Fermi probability function and this is the energy for different temperature. This solid line is for T equal to 0 Kelvin temperature, that means at absolute temperature, and this dotted line curve is represented the T greater than equal to 0 Kelvin temperature. So this is the Fermi distribution function. Okay. So in this way, mathematically we can reach or we can understand the Fermi distribution function at absolute temperature or at the greater than the 0 temperature, 0 Kelvin temperature. Okay. I hope you understand. Thank you. Thank you. I hope you love this informative session of NTA UGC NET or West Bengal SET exam. If you like my video, then please do like, share and subscribe my channel. फिर मिलते हैं एक नई वीडियो के साथ. Thank you.